Hello everyone, thank you for coming out to Exploiting Continuous Integration Systems and Automated Build Systems. I'm calling this part 2. Last year at PhreakNIC I gave a talk on kind of some similar stuff, but I didn't maybe go into as much technical detail as I wanted to. And then over the last year, developed an exploit framework, and I was able to present that at DEF CON, and then I've actually found some more stuff since the talk 3 months ago, and so I'm going to present that here as well. So hopefully you'll get something, you'll learn something, or we'll have a good time. I'm Spacebox. I go by Tyler as well. I'm the senior security engineer at a software company called LeanKit. We are based here locally in Franklin. I do mostly application and network security, but I also get my hands dirty doing like policy stuff and pen testing and sysadmin type things and access control. We're a smaller company, so you wear lots of hats, and I like to wear lots of hats. I also do security consultancy on the side. When my children and wife allow, attend the DC 615 group meetings once a month, but that's up in the air sometimes. What we're going to do here in this talk is basically go over a high-level overview, like a flyover of continuous integration and some of the concepts and what it is, and some of the tooling around that. And then we'll also go through a typical build chain flow for software from the time that code gets pushed to a repository to the time that it's deployed to production. And we'll talk about some of the problems that are inherent with these build models. And then also, I'll give a real-world example of an exploit, just a very basic one. If you saw the talk last year, it's the one from that. And then some bad practices that contribute to more exploitation, and then I'll give 2 real-world examples that are a little different, kind of unique to the vendors. And then after that, I've written a program called CIDR, and so I'm going to introduce and just kind of quickly go over what CIDR is. So we need to at least set some definitions before we really get any deeper. Continuous integration at a high level is the tools that are in place to quickly and iteratively release code into production environments. The goal, a lot of times for most, especially development type shops, is to have many iterative releases per day. That's kind of the dream, or per week. These systems, at least the ones that I'm going to be talking about, are mostly repository-centric, meaning the build process starts from the code that is pushed to repositories, and this code build process is in sync with the automated building systems as well as the automated deployment systems. And one thing to also note is the further this kind of evolves, it lends itself not just to development practices, but also to infrastructure practices. As you're having systems like AWS and Azure that you can deploy infrastructure components with templates, it just makes sense that these are repository-centric and that these template deployments get shoved out in the same way, oftentimes starting with pull requests and things like that. So we have to talk about microservices, but I won't harp too much on this because I've done so in the past, and it may not be pertinent to what everyone does. But microservices is the high-level concept that we're going to take a piece of software that acts as a unified whole, a monolith, if you will, and break it down into smaller components that do 1 or 2 things by themselves, and they do only those 1 or 2 things. And they can be developed autonomously by groups of developers who say, all right, you're going to build this thing, it's going to take X as an input, it's going to do Y and Z as the output, and if it breaks, we know what broke. We have this single microservice that's going to handle the left-hand toolbar on this nice app we have, and if the left-hand toolbar, gets borked, then we probably know which service it is. It's the left-hand toolbar microservice. So we're going to do tooling. I'm going to go briefly over the tools. I'm not going to spend too much time talking about specific ones until we get to the exploitation part. But these are things that I feel you can probably look up and research in your spare time. A lot of them are very in-depth and they have a lot of capabilities. we're going to be focusing on the portions that I've been able to exploit because that's more fun to me, and it's what I've been focusing a lot of my research on. The idea of a build system is to take the code and you build it conditionally. And what that means is, in some cases, it doesn't have to be very much. It could mean you print hello world and the code doesn't throw an error, and that's all that your test is. But really what this is a way to get a rough preliminary test on the code. It's not a QA framework or anything like that. But a lot of times these systems are quasi-containerized, meaning you shove your code up to a repository, it goes into the build channel, into the build system, and it builds it with these minor tests. And then a lot of times, like in GitHub, it'll send a signal back, like a thumbs up, and go, hey, your code didn't crash. And that lets the person who's going to be merging that request go, okay, it doesn't totally suck, and they don't waste their time. And that's not the entire purpose of the build systems. The build systems do a lot more, but in a lot of cases, that's what they end up getting used for. Some vendors are Travis CI, Circle CI, Drone, TeamCity, BuildKite. Jenkins falls into this category as well. Then there's the deployment systems, and there's a lot of crossover between the build systems and the deployment systems sometimes, but some of them are segregated, and so I decided to differentiate here. But the code, after it's built, goes to a system that then will find servers or find clusters of servers or find a container or a place to spin up a Docker container with that service in it after it's been built. A lot of times the build service actually will containerize and build an image of the built service and then shove that up to the deployment system, and now the deployment system just indiscriminately is just programmed to just find the right amount of space in the allocated servers and deploy it. So Jenkins would also fall in there, Octopus Deploy, Kubernetes, Rancher, Mesosphere. A lot of these are going to be container-based. That's kind of the direction that a lot of these are going. So I sort of verbally gone over it, but here's some pictures. Got Developer Man, he pushes up to GitHub. The build service has a webhook, and it sees, hey, a PR has been made, a pull request, or just a commit has been made. They trigger off various things. I'm going to pull that code down, and I'm going to do the build test with it. I'm going to build that code, and then I'm going to let the repository know, GitHub, that it succeeded. So once that's succeeded, then it might do something like I was just talking about, like build an image and shove it up to an image repository, different than the code repository. Or it doesn't have to do that. And then it will take that and push it down to a deployment system. And now that the deployment system goes, hey, this code is built successfully, we have an image and we have a target, we can then use the deployment service and deploy that out to those little blue squares at the top, or just servers or clusters or resources or whatever. So that's it in a nutshell. And so it's these systems and these interactions between these systems that we're really going to be focusing on exploiting. There are some trends that are developing in the kind of the development world that maybe aren't the most secure, and the need for speed pushes people to focus on quick releases versus the security of those releases. And so what we find happening, one of the big ones that I already sort of talked about was that one of the purposes of the build service is to let the person who's going to be merging it know that it's successfully built, meaning that before the code is actually approved to be a part of the code base, it's being built on a service somewhere, which means that anyone who has access to do that build has capability to manipulate that build service, even if they don't have permission to actually control the code in the repo. That's because they're triggered from PRs and commits. The thing is about these is the repository, in most cases, holds the downstream instructions for the build service. It holds a .travis.yaml file or a drone.yaml file or something in the repository that tells the next thing down what to do, which means that someone without permission who is just trying to do a pull request can now give instructions to the build service before it's even been approved to be merged into the repository. And that's kind of where I do most of the exploitation, is at that step there. And it can have big downstream effects. vulnerabilities lie, for the most part, in the idea that you have these interdependent systems that are being linked together with basically just webhook calls. And so you have a build service that's talking to a automated deployment service, but these have different user permissions. These have different access to your repository. It's hard to take one, like if you're in a company and you're trying to do a policy, like a user access policy, it's hard to take that policy and apply it the same to every one of these. So it's not necessarily the individual systems that will be taking advantage of. It's the misconfiguration in the interaction of these systems, which is where most of the vulnerabilities actually lie. In many cases, in most cases, it's actually the service themselves are operating just exactly as they're intended to function. And I think, personally, I feel that the most volatile like threat vector here are the external repos, particularly external repos that trigger builds on a company's internal build servers. So you have something where it's like, hey, we want to share our code base with the world. That's fantastic, until you are allowing the world to trigger builds on your administrative subnets, and then that's really bad. Let's see here. There are patterns that are evolving, especially in the build systems, where there are multiple ways to execute code or manipulate the way that those builds work, but the three biggest that I've experimented with are, in most of these files, for most of these systems, there's a section called pre and post commands. So before you test your build and after you test your build, what do you want this thing to do? And in most cases, this is where you can just inject Linux commands, like raw Linux commands, and in most cases they're actually running as root. So you're allowing in these pre-post commands to just run arbitrary code, which is fantastic. And this is, by the way, the section of the file that I kind of exploit the most because it's the easiest, but there are other ways to do it. One is the image specification. Some of these systems allow you to actually specify which Docker image you want to build from, and it will just blatantly pull down a Docker image to build on. So if you have a malicious Docker container, you can just pull that down. Or, in some of them, don't allow you to pull arbitrary images down, but they will allow you to supply a Docker file, so you can just build your own image, and that's even better. And then the last thing is, I think the newest version of Drone actually allows you to say, hey, I don't want any changes to the config file for the build in the code repository. Don't build it. That's dangerous, which is great of them. The problem is they don't seem to forbid you changing the test file that gets run. So all I got to do is inject bad code now in the test file, and you'll be able to bypass that feature. So real-world hacking. This was kind of the first time I discovered, and another person discovered too, the problems inherent with this. So you can kind of see here we have the image specification at the top. You had the environment where you did the environment variable setup, and then you have the command section here, which includes the pre-post commands that I was talking about. And so that's where you're going to inject arbitrary code. Then you have publish information after that in this example, where it builds the image and shoves it up to a repository, and then some plugins you can have to do alerting and such. In this case, a guy came up to me and was like, hey man, I think I can change an environment variable in the build, and I think that's bad. I think we can actively change environment variables. And at this point I wasn't aware of kind of what these systems did. I was still new to it. It's like, all right, let's take a look, man. And sure enough, he was right, you could change environment variables. But I was like, what's this command section do? And so then we just like injected like a echo statement, and I just wanted to see if it would reflect back, and it did, and I couldn't believe it. And so I was like, oh man, we could do a lot more than change environment variables. You know, it's like he found the treasure chest and then was like, hey, it's a really cool box. Yeah. I was like, no man, open up the box. So I did something like this in this command section to do a backpipe, and then pipe netcat back over it to my little control server where I'm listening on port, and so then from there, you're able to get root because most of these systems inherently run with root privileges. So that was the first example, but then it just like got my brain on a torrent of like, why hasn't anyone exploited this yet? And who's aware of it, you know? Like, I can't be the only one that's aware of these problems, but they are like relatively new, and when these systems come out, everyone just jumps on them. And then also, what's the attack surface? How big are these? How many repos in GitHub are actually have these and are triggering builds on servers and things like that? So before there is an older project, I think, Jonathan Claudius. I think he was at Mozilla. I'm not sure where he is now, or maybe he's at Mozilla now. I don't know. But he, in his spare time, did this project called Rotten Apple. It was written in Ruby, and it did kind of what I tried to do with my exploit framework to an extent. His was more auditing, and it audited Jenkins to look for things during the build and tell you, hey, this is potentially insecure. And it was really, really cool, and I liked that framework a lot. I felt like I wanted to do a little bit more with it, so I kept poking around with it. But other than his tool and a few white papers that I found that were really not very specific, I didn't find a lot of people that were doing this, so that's kind of what motivated my morbid curiosity. Let's see. Most of these systems are cloud-based, meaning if you sign up for a Travis account, you get a Travis instance in the cloud, and they run it, and you don't touch it. However, you can sign up for enterprise versions of some of these softwares and run them locally. In fact, a lot of these actually, there are some vendors that do local only. So you just kind of get a mix, and a lot of times you don't actually know what you're getting into when you find one of these. You kind of have to figure out if it's, all right, are they using the cloud-hosted version of Travis, or are they using the local version? Obviously, the local version has a lot more implications as far as taking over a network, but there's still bad things that can happen. I was kind of surprised that, I mean, it'd be inefficient and hard to control, because when you do these builds, they go into a build queue. But you could use these to take all public builds that are doing builds from a config file and do some sort of like malicious attack on something, because they would all start building in sequence, right? You take every single .travis.yaml file on GitHub and do a PR to it and just see what happens. I say yes, please, but I really am not condoning it at all. But I'm kind of surprised that hasn't been an attack vector that at least has been seen yet. Or I say mine Ethereum, but doing blockchain stuff on I just don't see that happening. But it would be funny. Because there's the Ether miners now that are out in taking over docile Reddit servers and stuff. Or not Reddit servers, Redis servers. But like I said, the on-prem stuff is really the biggest concern when you're running these services and you have an external-facing web hook that's going into your build servers. That's where a lot of this is going to lie. And then some of the fun stuff is altering downstream production. And this applies also to cloud-based, but there's a lot more implications of taking over a network when you can get control of an internal build server. All right, I'll stop talking about that now. There are some development things that are also need to be known in operations, like DevOps practices. One is, it's a common practice now to store credentials for other microservices in environment variables, so that it's technically better than storing a hard-coded cred in a config file in your repo. But since everything's repository-centric, the kind of other solution to that is like, hey, let's just shove it in an environment variable. Well, the problem is when you compromise one of those servers, all you have to do is type env, and you dump all of your creds to get to other services. So this, if you're thinking in kind of the typical attack vector kill chain, it's kind of like how you would pivot from one thing to another once you gain access inside. It's at least one technique. And the other big thing is that most of these are implicitly running things as root. And so when you take over, you just have root access. Now, a lot of these are on a stripped down image, like an Alpine image instead of a full Ubuntu image. But it doesn't really matter if you can talk out to the web, right? I mean, I can just start pulling stuff down through apt-get or whatever, or just start pulling down from my own personal tool set as long as I have web access. And then you have control to fully augment that image into whatever kind of image you want it to be. So the next example of something that I sort of found on accident was I was testing, I sort of got trigger happy once I kind of really delved into this, and so I was testing against, I was doing bug bounty stuff, which it turns out testing against the GitHub repositories is out of scope for most bug bounties, just heads up. But I was testing for a social networking company, and I tried to start messing around with their Travis stuff. And I just started doing basic recon, right? Here you have, I'm doing netstat, I'm getting computer name, I'm getting what's my external IP address, just basic stuff about the hosts that I was able to execute code on. Trying to, figure out where I was and what I was doing. I noticed that the external IP actually went back to a Google, like a Google cloud hosting, which I wasn't very familiar with them. But one thing that I noticed that was really unique was that I started seeing the Google Cloud stuff, and I knew that I was operating in Travis, and so I knew that I must have been in their cloud-based Travis build services. And I started seeing these environment variables when I did an environment variable dump for like gcloud paths, or gcloud something something, and I started to get really, really curious as to what that was. Most of my experience is in AWS and Azure, but I thought I would do some research. So I researched like what those were, and it turns out some of those references were to a gcloud CLI program, which is the way that you control your instance of Google Cloud. And this is something that the customer should never see, right? This is something that them as a company would be using to control their networks and deploy stuff. But I got curious, and I was like, what if I could just like shove one of those gcloud commands into the pre-built file and see if it worked? And it did. So I did this command, and it was sudo gcloud compute project info describe, just to see if I could at least list Google Cloud deployment information from their service, and I could, and it dumped out even like a like a public key there, and a bunch of stuff. So I was like, oh man, this could be this could be really bad. So I didn't stop there. I kept going, and I did this next one is Google Compute Networks create test network mode auto, and what that does is spin up a virtual network, and it worked. And so then you can see halfway down there underneath the smiley face where I was really happy that it worked, the other stuff verifies that the networks were created. Not only was the network created, but it was created in multiple regions across multiple continents. And so I was really surprised that I ended up actually just spinning up that virtual network from a two-line pull request to a repository that I didn't have permission to access. So I contacted them, and they were really happy. They were very grateful that I did that. Here's the full file that I ended up pushing their way. They were grateful, and they fixed it right away. Travis was really awesome about that. GitHub was not. They banned my account. They eventually unflagged it, but it turns out it's against GitHub policy to do pull requests or do anything to a repository that you don't own, even if you have permission from the owner. So I don't know how that works, but it's really a problem when testing, because even if you're approved pen tester going in, doing this thing, it's actually against your policy to do that. And then the social media company kind of was like, yeah, this is probably too intrusive for a bug bounty, but be warned. So this last one was one I found recently. This was a problem with a service called Drone, and the problem really is that the way these build systems work is you give them a list of steps, and like, let's say you give them a Docker file to build. Each one of those commands, like expose or add or any of the other Docker commands that go into a Docker file, actually end up getting run in their own instance of a container. So it'll spin up a small container real quick, it'll run just that step in the container, and then exit out and move to the next step. So if you have 50 commands in your Docker file, it ends up spinning up 50 things. But in the build service portion of that, the build goes the same way. So when you're not building the image and you're just doing the portions of the config file, it'll go through each one of those and run that in its own container as well. It should only share the kernel of the host that's doing the building. It shouldn't, everything that happens in those containers should not go out and have anything to do with any of the other steps. But the problem with this drone stuff is that it shared file system stuff too, outside of just sharing the kernel. And they were doing that on purpose. And that one of those shared things was the OAuth token to get into the GitHub account to pull the code down. So here's basically what it looked like. You can see here I'm doing different steps. There's the cloning of the repo, which is the only step that actually needs that OAuth token. None of the other steps need to talk to the, and it only needs read access. It doesn't need write access or anything else. But by default, that's not the way it's provisioned. It actually has write access. It can generate tags, and then these are just the various steps that spin up in containers. So once I got command over that, I actually threw back a shell to myself just to go exploring, and this is how I found it. I just found it in the home directory of the root user in the .NET RC file. It has blatantly the GitHub OAuth token there. That OAuth token is provisioned with access to commit to master. So I'm actually able to take that token and then write back to the master branch. So you can do commits to repos that you don't have any permission to be on. It also allows you to impersonate users. So you can actually use that OAuth token to be any user and do any action against any repo. And most of the time, that token is at an organizational level. So whatever repos in that organization have access to drone, you can now do anything to those repos. This is only the case, however, for private repos. If it's a public repo, they just do a git pull. So that is one thing to note, but I brought it up with them, and they don't really have a solution at this time as to how to fix it. So just something to be aware of, and I actually wrote an exploit and put that in my exploit framework, which we'll get to now.
Did they not just make it read-only?
That's what I was wondering. I was thinking, you don't need, I can't think of a scenario in the build service why you would want to have write access to the repository. Like why implicitly that service in GitHub, that when you install the drone service, why it would need to have write access.
Maybe to say it's okay or build successful.
Maybe it needs to maybe that's the permission it needs in order to talk back and say, yeah, the build succeeded.
It could be designed a lot better than just a check.
Yeah, right. They did say something to the effect of, well, you could have, you could come up with an API user specific to that and use that, but then you would have to, I can't remember what their solution was, but it was one of those things where it's like, that's not going to work at scale. It's going to work for a single repository, but it's not going to work for an organization with 300 repos. Yeah.
Just one quick question. It seems like a lot of your attacks are focused on access to the repo at almost a root level. So
correct.
And it appears that a lot of the things that you're going to show us are really focused on the fact that if you've got your environmental variables, you've got your build commands, all that stuff in the same repo, then it's wide open. So are you seeing any customers, because I've got any companies that are focused on maybe kind of separating that out and using key value stores to be able to hold their environmental variables?
Oh yeah,
and stuff.
Right. And
it seems like this is very, like, if you do it this way, you're just begging to be owned.
Kind of. These are common practices I see a lot. And like at our place of work, we have had to go out of our way to build key handling services. The one I built was called Key Handler because I'm super creative with titles. But that's what it does. And it speaks on behalf of the service to go leverage a stored key, but there's like Vault IO that kind of helps with that. So yes, like as far as the environment variable stuff goes, there are definitely ways to get around it.
Microservice.
Right. But even like the microservices themselves are like,
Another flaw that I've seen is apps that take the password info on the main line problem is anything else running on the same system can see that command line.
Right, the history, the bash history or whatever. Yeah, absolutely. Yeah, there's a lot of problems here. The entry into this, for the most part, I kind of mentioned I got further in once I landed, so to speak, but the landing part happens through the GitHub configurations and the build, just initializing a build process. And honestly, I haven't gone too much past that in weaponizing, image repository poisoning or anything like that, because I've just had a lot to do here, just exploiting the actual build service. So the tool that I introduced is called CIDR. It's the Continuous Integration and Deployment Exploiter, and it is a framework for exploiting CI build chains. It leverages GitHub as an attack service. I haven't really integrated I haven't integrated GitLab or Bitbucket or anything like that, but it easily could be done to those. I wrote the thing in Node, so it has some APIs that lend themselves well, not only to the Git framework, but to GitHub itself for doing pull requests.
You wrote it in what?
Node.js.
Okay.
Yeah. It was an experiment. I could have written it in other languages. I'm glad for the lesson in Node. But it handles callback shells really well, actually. It has really cool socket functions that lend itself well to handling lots of sessions. I wanted to take the mess out of forking and making pull requests to repositories, because let's say you want to test something. I have to fork the repo, I have to pull that repo down, make my change, push it back up, and then make a pull request to the target repo from my forked repo, and then hope that it works. And if it failed, I have to do all that over again, except for the forking, because I've already done that. And it was a pain, so it would take 30 minutes to test 4 different things, and then part of this was out of laziness. And what this can also do is take a bunch of repos, takes a list of repos, and then you load an exploit and say exploit, and it will figure out if they're the right kind of repo, if they're a drone or a Travis or a whatever, and then it will run the exploit for those. I did it for fun. I did it to make the attacking easy. I also feel like there's not a lot of awareness here about the potential for bad stuff to happen. And I still want people to know and contribute and help make these things more secure, because application code is being deployed in bulk, built off these systems in these similar patterns. And I also wanted to make it relatively modular, so that it could be easy to contribute to. If you had an idea for something, you can kind of look at one of the other exploits and kind of figure out how to write your own. So it looks like this. This is the command line. It's very command line-y, like social engineering toolkit or a Metasploit or something. I kind of wanted that vibe to it. Has basic help menu with help commands. You can add targets. So you would just say, right now it would be, it's expecting GitHub. So when you type owner/repository name, it's assuming GitHub. I would like to expand it, like I said, to other services, but right now that's just what it's doing. So I add a target. You can load said target. So you load the target name. You can get some basic information about what it does, and then you hit exploit, and it will dump. It'll dump whatever back at you. If it's a shell, an exploit that's supposed to call back a shell, I actually have a menu written in there to do shell handling. Otherwise, it'll just, if it's a recon exploit, it'll just grab all the recon info and then just dump it back on the screen too. One of the features, the way I do the reverse shells, which I actually tried to do this, and I'm hoping this sort of catches on and be really cool, is I use ngrok, which is a service for port forwarding public requests down locally for when you're testing code. It's a service, it's free. I think they have some sort of paid version for it, but this is a free thing. And so what I'm doing is I'm actually spinning up an instance of ngrok that's listening on a port, like a TCP port, and then I have my callbacks actually calling back to that, and then I tunnel it down locally. And what this allows me to do is not worry about port forwarding anymore. I don't have to worry about being on a public-facing web server anymore for getting callback shells. I can get callback shells like here, and the Wi-Fi behind, I'm tunneling it through that service. So this is like it in a nutshell, but it does all that implicitly. And it'd be really cool if more services started leveraging this, so you don't have to get on your pen test box that has a public IP or anything like that. Yep, this is my disclaimer that I sort of said before. You must be the owner of a repo, and you must ask them to make you an owner before you can test without getting yelled at, which is, probably not going to happen. I'm warning you. So, let's see here. I can't remember if I linked this video or not. I did. Do we have time? Are we good on time?
Yep.
Okay. Then I'll play the video of just an exploit. So, yeah.
Hit play,
Yeah, I hit play.
and then you just jump to a spot.
Oh, there we go. Okay. So here I'm listing the exploits. This is just some basic functionality, just so you know what the tool does. I'm going to load one of those exploits, in this case, the Travis Netcat reverse shell. So what this is going to do is pick from my list of targets, figure out which ones are Travis repos. It's going to fork and pull them down. It's going to poison them and then make a pull request. So there you can see the yellow means I've already forked it and I've already pulled it down, or already cloned it. And it found that 2 of them were Travis and then overwrote them and pushed them back up. I should have just cut this part out of the video, but it takes a bit for that to get queued and for the build to start. And once the build starts, then it'll trigger those and hopefully throw a callback shell to me. And it will say, it should say, the way I have it now is it will say the eagle has landed, and it will just arbitrarily pop on the screen, just so I know, like, peace of mind, hey, that shell actually called back. But then after that, I'll jump into the sessions menu and hop on the shell. So maybe I could just fast forward. Yay, okay, let's go back. There you go, they both came in at the same time. That was kind of odd. A lot of times they're staggered because you're leaving it up to the build queue of whatever that repo is. So now I can jump into the sessions menu just by typing session, and then list my sessions, and it sees that I have 2 active shells to those repositories. I select one of them, so just select in the name. And now I'm in the session. And who am I? I'm Travis. I'm now taking over that build server. Now this one is in the cloud, so it's taking over the actual Travis build server. So that's about it. That's kind of what it does. I also have a lot of recon and sort of information gathering sort of exploits that do the same thing just without the throwback shell. But I also added the drone exploit in to steal the OAuth cookies. So that's my newest one. Yeah. There we go. The limitations, like I said before, with the build queues. There's a lot of noise in GitHub, so if you're trying to be stealthy into this, it's not going to be the case. You're going to be just like firing off pull requests after pull requests, and it's going to be very loud. I actually thought about adding some functionality to clean that up so that you could go in and just go, yeah, close pull request, whatever. I haven't done that yet. The thing is once that triggers and builds and you execute code on the build server, who cares, right? I mean, you're one step past, it's too late, unless you're testing over and over and over, in which case they tell GitHub and they ban you. But the timeouts are another thing. I had to work around. Travis implicitly times out if it doesn't return after, if it doesn't see anything after 10 minutes, it shuts down. If it sees standard out, it will go up to 60 minutes or 50 minutes. And so I have a keep alive in the Travis ones that just keep it alive. It just prints keep alive every 30 seconds to keep that alive so I can get the full hour of time to do whatever I want with the callback shells. Others are different. I think the new version of drone has 60 minutes by default, but you can lower it down, and but they all vary. And also API request throttling. I'm leveraging the GitHub API, which I think has something like 500 or 5,000 requests per hour as its max. So if you want to really just spam like more than 5,000, because it'd be 2,500 repos because it's making multiple requests, then you're gonna hit that limit. So all things to consider. I'd like to add more CI frameworks. Everyone seems to use Jenkins except for me, so I'm going to be adding Jenkins support. I'm going to start tackling more deployment services as well. Right now I'm really just focusing on the build services. I'd like to get into repo poisoning and things like that. And there's a new movement called chat ops, which is kind of evolving in the DevOps community, which is triggering automation and infrastructure builds from Slack and other chat programs. So that's a new entry point versus doing pull requests. You can now maybe trigger some of these exploits through chats. So that's about it. These are my thanks to people that helped. And my information here is you can find me on GitHub, it's Spacebox with the 0. Twitter's the same thing. And I have a blog that's occasionally updated at untamedtheory.com. Thanks.